Hello, in this video we are going to focus on an Irodov problem in mechanics. The problem is this: your car starts moving rectilinearly, first with acceleration omega is equal to 5.0 meters per second squared. The initial velocity is equal to 0, then uniformly and finally decelerating at the same rate omega comes to a stop. The total time of motion equals tau is equal to 25 seconds. The average velocity during the time is equal to 72 km per hour. This is V with this notation which represents average velocity. How long does the car move? Uniformly, figured out 1.3. The whole motion of the body can be graphed like this. Okay, velocity on the y-axis, time on the x-axis. Initially, uniform acceleration is represented by OA, and A to B, uniform velocity, no acceleration, and B to C, uniform retardation with the rate same as the initial acceleration. Initial acceleration, final retardation are numerically same, and for a time t, it is moving with uniform velocity. And it's given total time of travel as tau, and the average velocity is also given. Okay, so now given, what are the things which are given? Omega. Omega is acceleration here, not angular velocity. Okay, tau. What is tau? Tau is the total time of motion. Right? This is average velocity given as 72 kilometers per hour, which we may have to convert into meter per second. How do you convert kilometer per hour into meter per second? Okay, simply multiply by pi by 18. You will get meter per second. Here it will be 20 meter per second. Multiply by pi by 18. You will get 20 meter per second. You can check also. How long does the car move uniform? Our aim is to find t. You are given tau, total time. You are given average velocity. You are given acceleration. Okay. Now, you see, you draw the vertical lines AD and B. A is the end of acceleration, where from uniform velocity starts. It starts from rest, and B is the end of uniform velocity and uniform retardation starts. And C is also velocity 0, and C is also velocity 0, and rho also velocity 0, acceleration and retardation magnitude wise same. Therefore, we can say that the two triangles here are congruent. And the shaded area, the total shaded area gives displacement. Right? The area below velocity time graph will give you displacement, and the slope gives acceleration. These are some basic things regarding kinematic curves. Now we will represent everything like this. OA, uniform acceleration, omega, starting from rest. See the figure. Then AB, uniform velocity. Of course, that is for a time t. BC, uniform retardation with magnitude omega, finally stopping. That's important because it is maximum velocity to zero velocity. This is from zero velocity to the same maximum velocity. Therefore, OD will be equal to BC. So, if total time is tau, this is t. The remaining time, tau minus t should be divided by 2. Tau minus t by 2. That will be OD. Also, it will be equal to BC. Now, how to find this tau minus t by 2? How to find this? Omega is AD by OD. OD is this. So, AD will be omega into tau minus t by 2. AD. That is velocity. That is maximum velocity omega into tau minus t by 2. What we are going to do, we will find the total area from the diagram of into base. You can take it as a trapezium. Instead of two triangles and one rectangle, take it as trapezium and find the area of the trapezium. area of the trapezium half into sum of the parallel sides AB plus OC multiplied by distance between the parallel sides, the perpendicular distance. That area will equal to average velocity into total time. That will give you distance. Average velocity given total time. So we will proceed. T be the time duration for which the car moves uniformly. All these things I just now explained. Since the acceleration to the maximum velocity from rest and deceleration from the maximum velocity to start are at the same rate omega, we have the triangles OAD and CPE are congruent. Omega equal to acceleration is slope of the line OA, right? AD by OD, but AD equal to omega into OD, omega as it is, but OD is tau minus T by 2. And same is there for PE also. Right? Then area of the trapezium half into sum of the parallel sides. This is T, this is tau, you can see here. So sum of the parallel sides into perpendicular distance between them, that is AD. AD is nothing but omega into tau minus T by 2 is equal to omega outside. Here you have tau plus T into tau minus T, tau square minus T square, 2 into 2, 4. That is equal to the total displacement. That is average velocity into total time. Our aim is to find T, don't forget this. So rearrange. You get, in this case, half into, that same thing, I just wrote it here also, half into tau plus T into omega tau minus T by 2 is equal to the same thing I repeated here, just for the continuity sake. So tau square minus T square is 4b tau by omega. You want to find T square. So take T square to the other side and solve for T square, or eliminate for T square, or you will get T square as T square equal to tau square minus 4b tau by omega. Therefore T is equal to, you should take square root. So tau square will take outside and put the bracket. But here there is only tau. So you divide by tau. Tau square is taken, but here there is no tau square. Divide by tau, multiply by tau, tau square will be there, that is taken. So T is equal to tau square outside. So the square root will be tau. Square root of T square, square root of tau square is 2. And other than that, square root of 1 minus 4b by omega tau. Square root we are putting because we are finding T, that is T square. So when you take square root, it has become tau. This one square root we are putting. Then substitute all the values, and then when you simplify, you will get the answer. What is the answer? 15 seconds. So 25 into root 1 minus 80 by 125. Simplify, get the answer as 15 seconds. Okay? Thank you.